In this video, we shall look at integration technique that involves algebraic substitution. And this technique is applied when the integrand has an nth root of a variable of integration or involves a rational function or rational functions of sines and cosine. In general, suppose we have y as a function of x, and y is given as the integral of f of x with respect to x. So in such a case, it then implies that dy dx is the same as f of x. The derivative of f of x with respect to x. Now, suppose we let x be a function of t, where t is a new variable. T is a new variable, and we can call this 1. And then you can see that if you differentiate x with respect to t, dx dt, we can say it's the derivative of g of t. We denote it like that. Again, we note that dy dt will be the same as dy dx times dx dt. Note that we already know that dy dx is f of x, so this becomes f of x times dx dt. We already know it's g prime of t, so we have dy dt as f of x g prime of t, but x is a function of t. And therefore dy dt will be the same as f of g of t, g prime of t. And we can say that dy will then be f of g of t, g prime of t dt, gt. And therefore y, if you integrate both sides, will be the integral of f of g of t, g prime of t dt. But remember that we had said that y is the integral of f of x, and therefore we shall have y as the integral of f of x with respect to x will then be equals to the integral of f of g of t, g prime of t dt. And you can see on the left hand side, we no longer have x. We no longer have the variable x. We have our new variable t. And we have finally substituted x with another new variable t. Let's take a specific example. For example, integrate x root of 3 plus 2x with respect to x. Note that this has nth root of a variable of integration. The integrand is 3 plus 2x raised to power a half. The nth root here is the second root. So this one, you can also write it as x, the integral of x, 3 plus 2x raised to power half with respect to x. Now we need to introduce a new variable which we shall call t. We can say that let t be 3 plus 2x raised to power half. Sometimes you can work with let t be 3 plus 2x alone. But for this moment, let's make the whole of this 3 plus 2x raised to power half to be equals to the new variable t. We can eliminate the root sign by squaring both sides, so that I have 2 squared is equals to 3 plus 2x. 3 squared is equals to 3 plus 2x. Maybe from this particular point, we can have that 2x is equals to t squared minus 3. And therefore, x will be the same as t squared over 2 minus 3 over 2. We shall come back to this particular expression or equation. X is equals to t squared over 2 minus 3 over 2 later on. So note t squared, we have introduced a new variable t, or rather x now is a function of t, and the next thing is we need to find our derivative dx dt. So if you differentiate both sides, this side with respect to t, you get 2t dt, and the right hand side we differentiate with respect to x, you get 2 dx. 2 is common, then you are left with t dt is equals to dx. Note that if you are not used to that way of differentiating, you can make x the subject, like the way you have done here, and you'll notice that then x is equals to t squared over 2 minus 3t. Dx dt, if you differentiate x with respect to t, you'll get 2 over 2t, which is actually t. Note that if you differentiate minus 3 over 2 with respect to t, you get 0, since we don't have a t then. So dx dt is equal to that, which is exactly this one. So exactly that. T dt is equals to dx. And therefore, we can now rewrite our problem here and replace x with t. So you'll see that the integral of x root 3 plus 2x with respect to x will then be the integral of, note that this x will be replaced by this one. You can see why we had to make x the subject. So t squared over 2 minus 3 over 2. And then remember the whole of this, the root of 3 plus 2x, the root of 3 plus 2x is this one, is equals to t. And then dx is the same as t dt. And now you can see on the left hand side, we don't have an x, and this will be the same as the integral of this is t squared squared times this t squared. We get t raised to power 4 minus 3 times t squared dt. Note that you can put the half out. 1 over 2, we can put it out. And when you integrate, you will get a half t raised to power 5 over 5 minus t cubed. Of course, over 3, the 3 and 3 will cancel, plus the constant of integration, plus c. But recall that our problem had an x, so if I utilize this space here to work out the rest of the problem, this one, we want to replace t with our value here that had an x, 3 plus 2x raised power half. But before we do that, we can simplify this and say it is the same as 1 over 10 times t cubed. So it is equals to t cubed over 10 times t squared minus 5 plus c. And this then will be the same as, if you replace t with 3 plus 2x raised to a half, like that, of course, over 10 minus times t squared. We noted that t squared is 3 plus 2x. So this is 3 plus 2x minus 5, of course, plus c. And final answer, we can say it's 1 over 10 times 3 plus 2x raised power 3 over 2 times 2x minus 2 plus c. And that is what we call integration by algebraic substitution.